Let's have a look at the very next question. The front views of two cars are shown in figure 5.1 to the same scale. Suggest which car has a greater stability and give two reasons. Now, here we notice the front view of two cars. We can understand that the of the two cars that are provided, the racing car has a greater stability owing to the fact that the racing car has a lower center of mass. There is also another reason which tells us why the racing car has a greater value of a greater aspect of stability. This is because the racing car has a greater surface area of tires that are in contact with the ground as compared to the family car. This means that the area that is in contact with the ground is greater for the racing car when compared to the family car. This means the weight or the pressure is most evenly distributed. Moving on to the next part, the cars have the same weight. Study figure 5.1 and suggest why the stationary racing car exerts less pressure on the ground. First, to answer this question, let us write down two formulas. The formula for pressure P is force over area. And when the two bodies are stationary, the force acting is nothing but the weight. So the formula for pressure realigns us. Pressure equals weight by area. We've already explained the previous part that the racing car has a greater surface area of tires that are in contact with the ground, which means there is a greater area of contact. And since area is greater or area is more for the racing car, the pressure applied is lesser. The family car's tires each have an area of 0.012 meters square in contact with the ground. The weight of the car and its contents is 9,600 Newton. Calculate the pressure exerted by the car on the ground. We've already discussed this. Pressure is force or weight applied per unit area. This is 9,600 over 0.012 meters square. And when simplified, we get the value to be approximately 2 into 10 to the power of 5 Pascal. This concludes the answer to our question.